which is delta S is equal to gamma. Are you good? Are there questions? So this delta W for W is the percentage change in wages for one additional year of schooling. Right? And so what we're saying then is gamma is what? What is gamma? What is the economic interpretation of gamma?
Percent change in wages for an additional year of school.
Exactly, right? So the interpretation of gamma is the percent change in wages for one additional year of schooling. So this is the interpretation of gamma. And we call this the marginal rate of return, right? So it's a return in the sense that for one, we're looking, it's a rate in the sense that it's a percentage change, and it's a return in the sense that it's the percentage change for one additional year of schooling, right? And marginal in economics, and when we say marginal, it's for a change of 1 unit in something, what's the change in the outcome that we're measuring, right? And so this is the interpretation of gamma. This is certainly something that can come up in the term. Like this, if I ask you, what is the interpretation of gamma, right? Also, we can see that gamma is the marginal rate of return. It's the marginal rate of return to school. Any questions on that? Okay. So we can go through a similar exercise for the experience coefficients, right? Now, what's going to be different here is when we take the derivative of the experience coefficients, right? That derivative is going to depend on, what's that derivative going to depend on? In fact, let's just do it right now. What's the derivative of log wages with respect to x? What's the derivative of log wages with respect to x? What's on the right-hand side? What's the derivative of beta 1 times x? Beta 1. Okay. What's the derivative of beta 2 times x squared? This is plus 2 beta 2 times x, right? And what's this derivative here? If we just look at the exercise that we did over here. What's the derivative of log wages with respect to x? If we go through the chain rule, what's that going to be? One over x times what? Times d of, hold on, d of what? Times d of w. Yep. Everybody sees this, so this derivative on the left-hand side is just 1 over x times dw dx, right? Can you see in the back, down this low? No. Can you guys go back see? You can't see down? Okay. So what I'm going to do is I'm going to take this here. Can I erase this middle board? Does everybody have what's on the middle board? Okay, I'm going to erase the middle board and I'm going to write that up here. Questions? All right, we're going to do this. All right. So let me do that again. So let's look at the returns to experience. We calculate a lot of derivatives in economics. If you're going to see how something varies with something else, you take the derivative of the thing that you want to see how it varies with respect to the thing that you want to see as it, right? And so the returns to experience is going to be the derivative of log wages with respect to x. And again, the derivative of beta 1 of x is what? Yep. And what's the derivative of beta 2 times x squared? 2. Beta 2 times what? X. Okay. Right? And so we can see that log wages, the derivative of log wages with respect to x is a function of what? It was a function of what? This is the derivative of log wages with respect to x. It is a function of what? What is it a function of? That's interesting. You're right in the face. Don't be afraid. I think I heard it.
The addings.
A function of what?
The addings.
It's no. What's x? What is x? It's right on the board. Experience, right? Remember what we said when we looked at the difference in earnings for somebody who had just started working versus somebody who was working for 18 months, and we said that that would be large or small. And why would we say that was large?
In the beginning, it's a bigger change than like 18 years down the road.
Exactly, because in the beginning you have a huge learning curve, right? So the difference in wages for like a new trainee versus like somebody who's been on the job for 2 or 3 years is going to be huge, right? Whereas the difference between somebody who's been on the job for like 20 years versus 21 and a half years is going to be comparatively smaller, at least in percentage terms, right? Because it's like the things that they needed to experience on the job, like they've already experienced it 19 years in. And so the way in which earnings are changing with respect to experience is going to depend on x. That's the intuition behind why this is a function of x. Everybody follows that so far? Who understands this? Raise your hand. If you don't, raise your hand. Okay, good. All right. Now this left-hand side, if we were to work this out using the chain rule, what would we get for the left-hand side? What's the derivative of x, of log wages with respect to x? No, just ignore this part. This is the wages are a function of x. What's the derivative of log wages with respect to x? We did it with the what's school like? 1 over w times what? dw dx. Everyone sees this? All right. And this is just beta 1 plus 2 beta 2 x, right? And we can say that this is approximately 1 over w, the incremental change in wages over the incremental change in experience is equal to beta 1 plus beta 2, plus 2 beta 2, right? And if we set delta x equal to 1, right? This is gonna, if we set delta x equal to 1, what we're saying is, what is the marginal rate of return to experience, right? That is, how much more do you earn with 1 additional year of experience? Right? So from equation 2, can everybody in the back see all the way down to here? You guys in the back can see here? Okay, great. So from equation 2, what we're going to get is just delta w over w is equal to beta 1 times the x here. You guys can catch me on this, right? That whole windup is about the x. If I make a mistake like this on the board, you raise your hand and just say, Professor, my mistake is here. Right? Okay, good. It's going to be beta 1 plus 2 beta 2x. Right? And this on the left-hand side is what? The percentage change in earnings, right? Good. So we're saying the percentage change in earnings is related to experience here, right? Now, and this is a function of x, right? So what happens, let's call this equation 3. I'm going to erase this board here. Can I erase this board? Do you all have this? Okay, good. Okay. What is the marginal rate of return to experience if x is equal to 0, if you have no experience? You can give me the answer. What is it?
Beta 1?
It's beta 1, right? And so what's the interpretation of beta 1?
Just the intercept?
That's not an interpretation.
Oh,
The
it's
wages you get was 0 years of experience.
Exactly.
Yeah.
Is it the wages you get? It's not the wages you get. We asked, what is the marginal rate of return for 0 experiences? So let's try again. You have it.
So it's how much you get with 0 years of experience if the score increases by 1 year.
Exactly, right? And so you can think about this as the percentage increase in earnings from being a newly hired person to a person with 1 year experience. Does that make sense? Because if we look here, this marginal rate of return this is the marginal rate of return to experience. The marginal rate of return to experience is beta 1 plus 2 beta 2x. So the marginal rate of return, 1 second, to experience is a function of x. Because we said that going from no experience to some experience is going to probably be a bigger jump than going from some experience to a little bit more experience, right? So when we set the marginal, when we look at what's the marginal rate of return for experience x equals to 0, what we're saying is take someone who's no experience, who just graduated from Clemson, right? Now, if you were to have 1 additional year on the job, what's going to be the percentage increase in your earnings? That's going to be beta 1. Does everybody understand that? Who understands that? Raise your hand. If you do not. You do not understand? Okay. All right. There was a question in the corner here. That's not. Okay, good. So beta 1 is the percentage change in earnings between newly hired employee and I'm going to put in parentheses an employee with no years of experience. Because you could have a newly hired employee who's coming from another job who has some experience, right? An employee with no years of experience. And an identical employee with 1 year of experience. It could also be the same person, right? It also could be like the percentage increase in your wages as you go from having no experience to 1 year experience, right? So I'll put also the percentage change in earnings as an employee goes from no experience, that's x equals 0, to 1 year of experience. X equals 1. Okay. Any questions on that? Okay, let us take a quick 3-minute break, and then when we come back, we'll resume.
Well, 2 days.